Good morning, ladies and gentlemen. Do this now. Pause the video and answer this question.
Wait a minute. How do you do that?
Ooh, a car is speeding at 38 meters per second.
What was that thing you're supposed to do?
The driver sees a cop. Oh yeah, how do we do this? Let's talk about the numbers. Don't forget.
What was that mining thing?
Ha, there we go. Word problem info mining. Read until you come to a number, write the number and its units down, identify what the variable is, and then repeat that until you've got them all. What is the question that they're asking for? What equation can you use to get that?
Okay.
Okay, again, do it. All right, let's do it. A car is speeding at 38 meters per second. 38 meters per second. Meters per second. That's got to be velocity of some sort.
It's a velocity.
The driver sees a cop, hits the brakes, and accelerates at, okay, so it tells me accelerates at negative 2.25. Is that right? Meters per second squared. Okay. For 4 seconds, the time. How fast will it be going now? So fast, it's like speed, which is velocity, right?
Yeah.
So I've got two V's here.
Which came first?
This one came first, so this has got to be the initial, and it wants to know how it's going after 4 seconds, so this has got to be the final one.
Okay, so you got all the variables identified. What next?
Okay, so I know this equation, I know this definition. But I'm trying to find this. Trying to find this one. Didn't we do this yesterday?
I think so.
Yeah. So we can multiply by t here because we've got division here. So to get rid of this, we multiply. I have to do the same thing on this side. These cancel. So we've got t times a equals v final minus v initial.
Yeah.
And then I can get rid of this, right? Because again, I want to get this by itself.
Yeah.
Opposite of subtraction is addition. I'm going to go ahead and add it over here. So let's make this look good. I'll say velocity plus this times this equals this. Sweet. Yeah?
All right.
Okay, let's plug it in. So I've got 38 meters per second plus 4 seconds times acceleration. I'm going to put these in parentheses. Negative 2.25 meters per second squared. And this is going to give me my V final, you say? Okay. Let me just go ahead and cancel some units real quick. And notice that I've got 1s here and I've got 2 here. So, okay, now I've got meters per second left. So that's sweet because isn't that my units for velocity?
It is.
Okay, and let's go ahead and plug this in. So I'm going to go 38 plus, I'm going to put a parenthesis, 4 times negative 2.25, close parenthesis, and I get 29 meters per second.
I'll bet that's the speed limit.
A car is speeding at 38 meters per second, so it's 38, and it has a negative acceleration, which means it's going to be slowing down, right? And this makes sense because 29 is less than 38.
Yep.
Good, okay. All right, let's rock and roll. So what variables have we used to describe motion? Ladies and gentlemen, please write these variables in your notebook. Let's see if I can get this. There we go. Great. Oh, that's left over from yesterday.
That happens all the time.
Okay, now that you've written this down in your notebook, what do we call these? I want you to label these in your notebook. We've got distance, position, change in position.
Which is also called?
Oh, displacement.
Oh, yeah.
So distance, position, change in position or displacement, time, average velocity, the change in velocity, instantaneous velocity.
Nope.
Oh, just kidding, I got too excited.
Yes, Mr. Boykin's wrong, you're right.
well, initial velocity.
But it's an instantaneous
Oh,
velocity.
you're right. Exactly. That's what I was thinking. I was
Well
like,
done.
these are both instantaneous velocities.
It's a good thing I'm not teaching anymore.
Initial velocity, final velocity, which again are both instantaneous velocities, and then average acceleration. Okay. Now that you've identified all of those, my next step is please label the units appropriately. What would the units be for each of these? Do it in your notebook. All right. So for these first three right here, they would all have units like meter of distance, meters, centimeters, kilometers, feet, whatever, you name it, miles, okay? All distance related. Okay, time, seconds. Velocity and change in velocity would both be meters per second. Oh yeah, and these ones too, right? Because they're velocity.
Yep.
And over here, it would be meters per second squared, or again, distance over time squared. Yeah.
Yes.
Okay. Now that we've got that covered, behold, the kinematic equations. Y'all ready for this?
May we have a drum roll, please?
Notice the emotional response. So when we look at this and we kind of freak out, lots of numbers, lots of letters, okay, that gets in the way of us being successful and using these equations successfully. So what we're gonna learn today is a very strategic way to organize what's going on in these equations so that we don't get scared. We are able to control our fear. Please write this down in your notebook. Okay, so here is what I want you to do. For every single variable that you have in this equation right here, you're gonna put a check mark. If the variable is missing, put an X. I'll do the first one with you. So you've got the D, I put a check mark there. I've got velocity final, I put a check mark there. I've got initial velocity, check mark there. I've got time, check mark there. What am I missing?
No acceleration.
So I would put an X right there. Go ahead and do the rest.
Go ahead, boys and girls. Pause this.
Check your work with mine, please. So how do we even use this?
Well, each one has got a different missing equation.
Yeah, and there's five variables up here, 1, 2, 3, 4, 5. But each equation only gives you 4. 1, 2, 3, 4 here, 1, 2, 3, 4 here, 1, 2, 3, 4, 1, 2, 3, 4, right? Okay?
Yeah, which one appears every time?
Which one? Oh, initial velocity. So you'll always have that in the problems that we're using, we're trying to solve. So how do we use this? I'm going to go ahead and put some words on the screen for a moment, and then we're going to come back to this. So we're going to use information mining, which we just talked about, to figure out what variables we have, just like we did for our warm-up over here, right?
Yep.
And you're going to figure out what variable is missing. And what I mean by that is, for example, acceleration will be missing here. Distance will be missing in this case. Final velocity, time, okay? So you read the question and you need to figure out which variable is missing. And you're gonna select that equation, select the equation missing that variable. So, for example, if I had a word problem that had all 4 of these variables but did not give me acceleration, I would use this equation.
That makes sense to me.
Yeah. Okay. So now that we sort of kind of know how to use that, let's go ahead and take a look at your assignment for today.
How do you do this?
How do you do this? I'll use this. Okay. All right. So here is your assignment. Okay. That side is good. Okay, page 111, 112, so you guys are going to have to go to the e-text to find this. And problems 46, 48, 49, 40, 41, all that's okay. So 46 is the one that we're going to do. 46, okay. So let's go ahead and write down all the variables that are given. Oh, very, very clear. No numbers, no calculators, nothing yet.
Yeah, we don't want to
Just-
know what the answer is. We want to know how you do this.
Just the variables. So we're gonna write down all the variables that we find here. So it says a car with a velocity of 22 meters per second. Ooh, okay, so I'm just gonna write V, right?
Yep.
Okay, so velocity of 22 meters per second is accelerated uniformly at a rate of 1.6 meters per second squared. That's acceleration, yeah?
Yes.
How did I know that?
It tells you.
It tells you, right? It accelerated, and if you're unsure, look at the units. For 6.8 seconds, okay, that's time. What is the final velocity? Oh, sorry. Variable to solve for. The final velocity, okay?
That means that other velocity must be the...
Initial velocity. Okay. So out of all 5 variables that we have up on the screen, which one are we missing?
There you go. That's the question.
Which one are we missing? Well, we don't have displacement. So we don't have displacement. So that means that we're going to use this equation right here. So the missing variable is displacement. I was going to try and use that to do it, but then it's a little hard. What equation should we use? And if we look up there, the one with the missing D is V final equals V initial plus AT. Sweet.
Now, it's already solved for V final, so we can leave that blank.
Yeah, so we're trying to find V final. We have V final alone over here. We're good to go. Okay, your job is to do the rest of them. Go ahead and begin.